Hello everyone, this is Himabindu from the Department of CSIT. Today in this video I would like to describe about millimission, conversions of millimissions to moremission. In previous videos we have discussed what is meant by millimission and what is meant by moremission and what is the finite automata with output and without output we have discussed in the previous videos. And also we discussed about the conversion of moremission to millimission. Today in this video we would like to describe about the millimissions to moremission. So let's describe with the examples. So here we have taken one example. By seeing this example we can say that it is a millimission. So in this millimission, what is the main thing is we have the input as well as output. So here by seeing this diagram we can say that it is a millimission. Now we have to convert this millimission to moremission with the transition table. So for this one, first step what we have to do in a sense, we have to construct a transition table for the millimission. So let's find what is the input symbol here. So input symbol is nothing but a sigma. What are the input symbols? A, B, AB, and all the input symbols are A, B. And what are the output symbols for this millimission? 1, 0, 1, 1. So what are output symbols are nothing but here 0, 1. So let's construct a transition table for the millimission. So here how many states are there here in this diagram? In the sense we have 4 states. So let's draw that 4 states. So transition table for the millimission is having the input as well as output. So here we have to take input symbol and output symbol for the input symbol of A, and we will take input symbol and output for input symbol B. So let's find what are the states for input symbol A, and for the input symbol A what is the output in this diagram. So from Q1 when giving output input A, it is going to the state Q1 and giving the output 1. So from the state Q1 when we are giving input B, it will go to Q2 and with the output 0. And from the state Q2, when we are giving the input symbols A and B with the output 1, it is going to the Q4. So from Q2, it is going to Q4 while giving the input A and with the output 1. And here also by giving the B as an input to the Q2 state, it is going to Q4 and giving the output 1. And from the Q3 state, when we are giving A as an input, it is going to the Q2 state. So here from Q3, we are giving A as an input symbol, it is reaching the Q2 state and with the output 1. And as same thing, B as an input and it is giving 1 as an output to the Q3 state. So it is going to Q3 state itself with the output 1. From Q4 state, when we are giving A as an input, it is going to Q3 and with the output 0, and Q4 when we are giving B as an input, it is going to Q1. So Q1 and with the output 1. So here we have constructed a transition table. So by seeing this transition table, we can construct this millimission to moremission. How it is in the sense, let's move on to this one. So here what we have to do in the sense, first we initialize this one. So initializing with the Q1. So Q1 we have to check with the outputs. So from the state Q1, how many outputs are going? So here from the state Q1, it is Q1 1. And any other states Q1 1. So here no other, like Q1 is having the output 0. Let's check. Q1 is having 1, no other states. Q1 is having only 1. So here the same thing. So what representing in the sense, the state itself, it is having the output same entire transition table, so that is not having, not going to be slitted. So here what we will take Q1 as it is, and Q2. Let's check for the Q2 state. So Q2 state here it is having 0 as well as Q2 with the output 1. So here for the state Q2, we have to split that Q2 into two things. So how we have to split in the sense Q2, and we have two outputs. So two outputs are 0, output 1. So with the 0 output, so Q2, how to define that one in the sense Q2 0 and Q2 1. So this is the output. We have to mention with the next digit as an output. So here we have to split it this Q2. And again, let's check for the Q3. So Q3 is having Q3 1. So 1 as an input, and here also we have two different outputs. So for this one also we have to split that Q3 state into two things. So how we have to split in the sense, we're taking 0 as an output and 1 as an output, Q3 0 and Q3 1. Here we have to split that Q3 into two parts, like with the output 0 and with the output 1. And let's check for the next state Q4. So Q4 is having 1 as an output, and here also Q4 is having 1 as an output, no other remaining. So we have finished this. The Q4 is having the same output, so no need to split that one. So only the two states we have to split. What are those in the sense? Q2 and Q3. And same thing. And for this one, what we have done in the sense, the Q1 as it is we have written. Let's draw the Murray table. So in this Murray table, what we have, this is the output. This is the next state for A as an input and B as an input. Along with output, we will write. And here, so we have divided the Q2 into two states, right? Q2 0 and Q2 1. And Q3 also divided. So Q3 0 and Q3 1. And next Q4 as it is we have placed it. And we'll check. So here we have written the Q1 and Q2. All the states we have written in the Murray table also. And here first step what we have to do in a sense, we have to start with the initial state. So from the initial state, when we are giving A as an input, it is giving the same output. So here the Q1, it is going to Q1 itself with the output 1. And here Q2 and while giving a B as an input, it is going to the Q2 state. So here Q2 state, in the sense here we have to find Q2 0. Why we have to move to Q2 0? In the sense, we have divided the Q2 into two outputs. Like when we are getting the 0 as an output, it will go to Q2 and it will go to Q2 1 when we are giving the output 1. So here we already know that Q2, it is having the output 0, so it is moving to the Q2 0. Q2 0 with the output 0. And Q2 0. From Q2 0, it is going to B as an A as an input, and it is going to the Q4. A as an output, A as an input, and it is going to Q4. So Q4 as it is and 1 as an input. And next So Q2, from Q2 B as an input and it is going to save. So this is the same thing we have to. So Q4 is not splitted, so we can directly write it. And next Q2, Q21. From Q21, it is having Q4 and the same thing is going to be repeated. And from the Q3, so it is going to Q1 and with the output 1. So it is, we have to write this one Q2 1 and with the output 1. So and Q3 1, Q3, from Q3 B as an input, it is going to Q3 itself with the output 1. So it is a Q3 1. Q3 1 with the output 1. From Q3 1 also it is going to Q2 1 and 1 and Q3 1 1. So from Q4, so Q3 0 and Q1 0, Q1 1. Q3 0 with the output 0, Q1 1. So here it is the Moore mission. So here let's find out the outputs. So here whatever therefore Q1 output, what is the common Q1 state is having the output. So every time we are getting the Q1 as a 1 as an output. So here 1 is the output for Q1 state. And Q2 0. So from Q2 0, so here it is a Q2 0 is nothing. So here Q2 0 is having the 0 as an output. So it is having the output 0. And for Q2 1, it is having 1 as an input everywhere. Let's check this. So Q2 1 is having 1, Q2 1 is having the output 1. So no other Q2 1. So let's move to the Q3 0. So Q3 0 is having here 0 as an output. So no other Q3 zeros are there. So we will write the Q3 0 is having the output 0. And Q3 1. So Q3 1 is having the 1. So here the Q3 1 is having, this 0 and 1. And Q4, every time we are getting the Q4 state is having the 1 as a output. So here is the Moore mission what we have constructed from the Mealy mission. Let's draw the same thing with the transition diagram. So Q1, so let's start with the starting state, and when giving A as an input symbol, it is going to, so as it is a Moore machine, let's draw with the state it having the output also. So for the Q1 state, it is having the 1 as an output. So and A as an input, it is going to state itself, and B as an input, it is reaching Q2 0. And what is the Q2 zero's output is 0. And so Q2 0, from Q2 0, it is reaching the Q4 state with the output 1, A as an input, and so also having the B as an input, it is going to Q4 state only. And Q2 1, so Q2 1, if you give Q2 1 as an output, and if it is having the input symbol A, it is going to Q4, and it is going to, and next Q3 0, it is having the output. So let's draw Q3 0 with the output 0, and Q3 0, it is having A as an input, it is reaching Q2 1, and it is reaching, next we have to draw Q3 1 one as an output and B as an input. It is reaching Q31. So Q31 itself, it is having the B, sorry, Q31 itself. So Q31 itself, it is having the B as an input, and when we are giving the Q A as an input to the Q31, it is going to Q21, and next for Q4. So Q, it is when we are giving A as an input, it is going to Q30, and when we are giving B as an input, it is going to Q1 itself. So this is how we have to construct a mill emission to Moore emission. And let's do with the other example. So here we have taken one more example for the construction of mill emission to Moore emission. So here what are the inputs and outputs? First one, what is the input here? 0, 1, and output also 0, 1. And let's draw this transition table for this mill emission. So what is the transition table contains for the Moore emission? So here for the state A, for this input A, input 1, input 0 and input 1, and what is the state, next state, and here output, and here also next state and output. And here how many states we have? So Q1, Q2 and Q3. So here we have 3 states. Let's check with 3 states. So here the next state Q1 to, when we are giving the 0 as an input, it is going to Q1 itself, and with the output, here it is the input, this is the output. So 0 and 1 as an input, it is going to Q2 and giving the output 0. And for the Q2 state, when we are giving the 0 as an input, it is going to Q2 and with the output 1. And when we are giving the 1 as an input, it is going to Q3 and giving the output 0. And from the Q3 state, when we give 1 as a 0 as an input, it is going to Q2 state with the 0 output. And Q3, so Q3 1 as an input, it is going to the self loop. So 1 giving the output 1. So this is how we have constructed a transition table for the mill emission. So let's convert, by using this transition table, let's convert this mill emission to Moore emission. So here we already know that. So by seeing the input output symbols for the every state, we will divide that states into 2 things. So according to how many outputs we have to divide that many states. So let's check for every state what is the outputs of every state. So Q1 is having 0 and there is no Q1 0. So we will directly write Q1 as it is, and Q2 0. So here Q2 0 and Q2 1. So we have to divide that Q2 into 2 states like 0 and output 1. So how to divide this 0 input, 0 output and 1 output. And for the Q3 also we have 2 outputs. So we have to divide that Q3 into 2 states like Q3 0 and Q3 1. So no more states are there. So as it is, Q1 we have to place as it is, and 2 states has to be split. So let's draw the transition table for the Moore emission. So what is the table? Transition table contains in the Moore emission in the cells. So here are the transition states Q1. So Q1 I am not going to be split. Why? Because the only output is having for the Q1. So for Q2 it is having the 2 states like 2 outputs. So I have divided that into 2 states. And for Q3 and Q3 also it is divided into 2 states. And for Muri mission, we have to write for next states for input 0 and next states for input 1. And what is the actual output of this Muri mission? So let's find what are the states we have. So Q1, when giving the 0 as an input, it is going to Q2 Q1 itself. So Q1 with the output 0, and from Q1 it is going to Q2 0. So Q2 0 with the output 0, and from Q2, so it is having the 0 as an input, it is going to Q2 1. So Q2 1 with the input output 1, and from Q2, when we are giving a 1 as an input, it is going to Q3. So Q3 0 as an output. So we are writing directly the state name. And here from Q2 1, the same we have to repeat. And from Q3, so Q3 state, it is having the Q2 0. So Q2 0, 0 as an output. Q3 1. So here we have to write Q3 1 as an output. The same thing we have to repeat. Q3 1. So let's find what are the outputs for every state. So for every Q1 0, so it is having only one Q1 0. So we will write the same output here for the Q1 state. And for Q2 0 state, so how many states for Q2 0 it is having? Every time it is having the 0 output. So we will write 0 as a output. For Q2 1, it is having the 1 input. So we will write 1. So for Q3 0, it is having the 0 input, 0 output. So we will write this one. And for Q3 1, it is having the 1 output. We will write this. So let's construct the same table in a transition diagram. So how many states are there? We have to initiate this one Q0. Sorry, in Muri mission, what we have to write with the state or with the state name, we have to write output also. So Q1 with the output 0, and so when we are giving the 0 as an input, it is going to state itself Q1 and Q2 0 with the output 0. So when we are giving the P1 as an input, it is going to Q2 1. So for the Q2 0, it is having so B as A as an input, 0 as an input, it is going to Q2 1. And 1 as an input, it is going to Q3 0 with the output 0. So, and from the state Q2 1 itself, it is having the 0 input symbol, and 1 as an input symbol, it is reaching the Q3 0. And from Q3 0, it is going to Q2 0 with the input symbol 0. And we have to write one more state. So while giving the 1 as an input symbol for the Q3 0, it is going to Q3 1. And from Q3 1, so when we are giving the 0 as an input symbol, it is going to Q2 0. And for the Q3 1, when we are giving the 1 as an input symbol, it is reaching the Q31 itself. So this is how we have constructed a Mealy mission to Murray mission with the transition diagram. So these are the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.